Okay, so for our next problem, a wooden box with a mass of 45 kilograms slides on a wooden ramp with an incline of 65 degrees. What is the acceleration of the box along the incline, and what is the force of friction on the box? So let's go ahead and draw out this incline. It's going to look something like this. This is theta is going to be 65 degrees. We have a box, and it's got a force of gravity pulling it down, a resulting force in the x, a resulting force in the y, and a resulting force of friction. Okay. So we're being asked to find the force of acceleration, or the magnitude of the acceleration along the incline. So the acceleration going this way, and we're being asked to find the force of friction on the box, which is the force going this way. So in order to find the acceleration, I need to find the F net parallel to the ramp, okay? So my F net is going to equal my force of X, we're calling X parallel to the ramp, plus my force of friction, which is going to be the opposition force, the resisting force. And then my F net will also equal ma, allowing me to find the acceleration along the ramp. But I'm also being asked to find the force of friction. The force of friction will be given by negative force normal times mu k. Okay? So let's see. Force normal, in this case, it's going to be the amount that the ramp is pushing back on the box, which is going to be dependent on that angle there. So really, my force normal is going to be the force of y. All right, so I'm going to need to use some trigonometry to figure out the effective gravity on x and the effective gravity on y. So let's go ahead and label out our variables so that we can make some amount of sense of this. F net, Fg, Fx, Fy, force of friction. Okay. And then mass, gravity, and resulting acceleration in x. Gravity, I know, is negative 9.8. Mass was given to me, that is 45 kilograms. I want to account for theta as well in my variable list, and that was a 65 degrees. What else? What else do I know? Then I know the coefficient of friction, which is 0.2. Okay, because it's wood on wood. So let's go ahead and start figuring this out. We've got a lot of blank slots in this variable list. So if for whatever reason I wasn't sure how to go about finding this acceleration or how to go about finding this force of friction, just by looking at all the forces I have involved here, I could just start by trying to figure out the different forces that I don't have identified. So I go, okay, well, I don't know how to find the rest of this stuff, so at the very least I can find force of gravity, okay? Of course, I can find force of gravity. That's just mass times the acceleration due to gravity. My mass is 45 times negative 9.8. Easy. Negative 4, 4, 1. Okay, what else can I figure out? Well, I know that x and y are both results of that gravity, so first off, I'm going to find x and y. That's going to be given by the sine and the cosine. In this case, I'm going to translate this angle up to here. Okay? It's going to be the same angle. The angle right here is going to be the same angle between my force of gravity and my force of y. And then I'm going to throw in the force of x right there. And now I've got the three sides of a triangle. Simple enough. the opposite side of this angle is the force I'm using parallel to the ramp, which I'm calling force of x. So that's going to be sine of theta is equal to the opposite, which is my Fx, over my force of gravity. Rewriting that, I say force of gravity times sine theta equals Fx. Then I'm going to do the same thing for the y, except instead of sine, I'm going to use cosine, because in this case, the y is adjacent. So, force of gravity, cosine theta is equal to Fy. So let's plug our numbers into that. So force of gravity, I said, is negative 441. Negative 441 times sine of 65 should equal Fx. The same thing here. So negative 441 times the cosine of 65 equals F in y. So let's go ahead and calculate those. So that's going to give me, in x, a negative 399.7 newtons. In y, it's going to give me a negative 186.4 newtons. I know these are negative. That makes sense because this is force going down, and this is applied force in this direction as well. So both of those are in the downward direction. So it makes sense that they should be negative. Now, if I want to find the force of friction, I actually need the force normal, which is going to be the negative version of force y. Remember, force normal is equal to negative force y. In this case, because the force y is the gravity that's actually pushing against the ramp. Not all of the gravity is being used to push against the ramp. So, force normal, force of friction is going to be given by negative force normal times UK. Now the other way I can write this then, since force normal is just negative force in y, force of friction equals force in y, because negative and negative make positive, times the UK. Okay, so let's plug in our numbers and to determine the force of friction. 186.4 times a 0.2. And that's going to give me a force of friction equal to negative 37.3. So, negative 37.3. Okay. Now I've got my force in x, I've got my force of friction. I can find my F net. Great. So we've got x and F. Yeah. Nice. Great. F and x is that negative 399.7. Ooh, wait a minute. Okay, I made a little bit of a mistake over here. My Fx should actually be positive. Just for the sake of how we're working this problem, I'm basically using a reference that is at an angle itself. So this should be positive, positive, negative, negative. So because my Fx is going to the right, I'm going to say it's positive because I know my F net has to be the Fx losing the force of friction, but it's a summation of these forces. So for the sake of the problem, I need to keep my signs straight. This will be easier once we hit our vectors unit and we actually start to apply a little more complexity to this, because we're going to see that each vector component has a positive and a negative piece. Okay? So in this case, this is going to be positive. Now, Fx plus Ff is going to be 399.7 plus a negative 37.3. Okay, and that's going to give me an F net equal to 362. Now notice, I got most of the way through this problem before I realized my mistake of Fx versus Ff. I expect that that's going to happen with you guys too. So don't worry about it. But as you go along, you should be thinking about this. Does this make sense? Does this actually make sense the way this is set up? Okay, now that I know my F net, I can find my acceleration. So my F net is 362 newtons equals M, which is 45 kilograms times A. So if I take 362 divided by 45, that will give me 8 meters per second squared for acceleration. So my final answer is 8. And then I also wanted to know the force of friction. There we go. This is boxed off. We're good to go. Thanks, guys.